In this section, we're going to look at hydrides and Grignards as nucleophiles. So in this case, if we have an aldehyde, R bond C, double bond O, bond H, an aldehyde, and we add a source of hydride, specifically sodium borohydride, and we add ethanol, the H minus will come in here, and then the ethanol can provide a proton here, or sometimes these are followed by adding H3O plus in the second step. So basically H minus comes in, kicks this up, forms O minus, and then this is protonated by something. And what we get is R bond C bond OH, bond H, bond H, a primary alcohol. Now in this chapter, we're calling this adding hydride to an aldehyde or a ketone. We'll do a ketone in a second here. But in a previous chapter, we called this reduction. Okay, aldehydes can be reduced to form primary alcohols in this exact way. Let's look at a ketone, which is very similar. Here we have R bond C double bond O bond R prime ketone. We add our NaBH4 in ethanol. All right, and what we end up with is R bond C bond OH bond R prime bond H, a secondary alcohol. So that's the only difference, is that instead of a primary alcohol, we form a secondary alcohol in this case. So aldehydes and ketones can be reduced using a reducing agent like borohydride, all right, sodium borohydride here, in order to form primary and secondary alcohols. We've seen the mechanism of this before, but it fits along with this chapter, so there's no sense in seeing it one more time. Here, we'll take a generic example where this could be either an aldehyde or a ketone, but I'm making it look more like a ketone, and we've talked about this in previous sections. So here we have a source, we have B, H, 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 H minus. And we talked about borohydride before. This wants to get rid of H minus, said another way, it's a source of hydride, because if it were to get rid of H plus, you'd have 2 minus boron. If it gets rid of H minus, you have neutral boron, which is more favorable. So it gets rid of H minus, or hydride, like so. And what we end up with is R bond C bond O minus bond R prime bond H, like this. Then we have some source of protons. I'm going to use water as my source, but it probably could also be ethanol as the source. Here we have a source of protons, or we could add acid in a second step. So in this case, this will grab a proton, and we end up with R bond C bond OH bond R prime bond H. So H minus here is acting as a nucleophile in this type of reaction, and the carbonyl carbon is acting like the electrophile. Let's look at Grignards, and you'll remember Grignards are important because they can make carbon-carbon bonds. So in this case, we have R bond C double bond O bond H plus R prime prime MgX, usually magnesium bromides, and we typically do this in ether and subsequently add H3O plus. In this case, this bond is partially negative, and this bond comes in here, kicks this up, followed by a protonation, and what we end up with is R bond C bond OH bond H bond R prime prime. So in this case, we end up with a secondary alcohol, but most importantly, we've made this carbon-carbon bond. That's very good. This also works with ketones. If we have RC double bond O bond R prime, and we add R prime prime MgX or MgBr, in the presence of ether, followed by H3O plus, we end up with R bond C bond OH bond R prime bond R prime prime, the tertiary alcohol. And we've looked at the mechanism of this one before, but it's worth doing it one more time. If we have R bond C double bond O bond R prime plus R prime prime MgX. Again, this bond is partially negative. Said another way, this electron pair can go here. Now in your book, it'll show that the Mg is helping to stabilize the positive charge on the oxygen by, kind of sitting up here. And there's nothing wrong with that. It's just a little bit more complicated to draw, and it's probably more accurately what's actually going on in solution. But I'm just going to consider this as a minus charge on R prime prime, and these electrons acting as the nucleophile, going here and kicking this up. And what we end up with is R bond C bond O minus, bond R prime prime, bond R prime. We add H3O plus, and this attacks, and we get R bond C bond R prime, bond R prime prime, bond OH, like so. So whether it's H minus or R prime prime minus, kind of, okay, coming from the Grignard reagent, they're adding to the carbonyl carbon as a nucleophilic addition, as we've talked about several times throughout this chapter. So let's look at two examples where we can actually complete the following reactions. In both cases, we're going to start with acetone. So again, simple molecules are chosen. There may be some practical reasons why these would be difficult reactions to complete. All right, so we have acetone, and here we have another acetone. And we have some reagents to put in here. All right. In the first case, we get CH3, C, H, CH3, OH. So we go from this molecule to a secondary alcohol, a ketone to a secondary alcohol. Well, what do we need to add to this carbon that it didn't already have? We needed to add an H. How do we add an H to a carbon? This is your example of NaBH4 / ethanol. All right, we've reduced a ketone to a secondary alcohol using the reducing agent, sodium borohydride. In this case, what we end up with is CH3, C bond OH, bond CH2, CH3, bond CH3. So what's the difference between these two molecules? Well, in this case, I again went to the alcohol, but what did I add to the carbon? I added a CH2, CH3. So borohydride is not going to work, right? This is only going to add the H. This is not going to add this group. So probably not surprisingly, based on what we just talked about, we're going to use Grignard reagents. In this case, we're going to use CH3, CH2, MgBr in ether. Why are we using ethyl magnesium bromide? Well, because we added an ethyl group to this molecule. And then in step 2, we're going to add our H3O plus. So we essentially have ways to do reduction or to add H to this carbon and make the alcohol. And we have a way to add a carbon-containing group and make an alcohol. In the next section, we're going to look at nitrogen-containing groups and imines and enamines.